All right. Morning, morning. Ben, you didn't sleep at all? How can you sleep, dude? Tell me why. What the heck is a haiku? Haiku. Morning, Lucas. It's an anime. What's you doing watching an anime? Which one? Oh, yeah, you told me it's called Haiku. Oh, sorry, Ben. Please stop staring into my soul. It's 8 minutes before class. None of you ever show up to class normally that early. Oh. I guess it's just because you got to open up YouTube on your phone. Kathleen, why didn't you sleep? You weren't playing Apex, were you? Hey, Ruth. Welcome. Hey, Jared. Welcome. Eric, good morning. Oh my. What y'all talking about? Math is bonkers. Oh, that light is so aggressive. I don't even know how to put food as my background, Kathleen. I'll try. Picture of food. That looks delicious. Alright, we're getting there, Kathleen. We're getting there. Image. What am I going to call this? Food. Wait, where did I put that picture of food? Oh, I didn't actually download it as a picture, sorry. One moment. Dang it, why is this so annoying? Shutterstock is killing me. Okay, well, I'll just put spam or something. That's better. Is this gonna download? No, what? How come it's not saving pictures? There we go. Almost there, Kathleen. This better be worth it. There we go. Delicious food. What do we got here? We've got an egg, and then a chicken leg, then a pizza, then salad, then some... I don't know what that is. It's like congee, maybe? Some sort of breakfast soup. A shrimp. What looks like a fortune cookie, an ice cream cone, fried egg, ham, some sort of sandwich, ham and cheese, BLT. Is there a chicken leg in that soup? That looks like some rice and soup. That looks like some more rice, some sort of shish kebab, a pie, some pancakes, hot dog, taco, tomato sauce, sushi, bowl of rice. There's a lot of rice going on here. Looks like a multicolored ice cream ball, cake, bacon, burgers, tacos, pasta. Ooh, sushi kit. There's a lot of sushi. I also don't know what that next one is. Like a little one of those little pancake things. What's behind my head? It's like frozen ice. Birthday cake. There's some fries and a steak in the bottom. Oh, and if it's not a taco, what is that thing? All right, we are at 8 o'clock. The reason there is food behind me. Oh, sorry, Kendra. I apologize for these little food emoji looking things for messing with you. All right. Well, We do have our Bible reading this morning, so I'll just read the Bible verse Mrs. Kennedy posted. She also posted a pretty cool little story with it. But here's your Bible verse. So it's from James 1, verse 27. So it says, "Religion that God our Father accepts as pure and faultless is this, to look after orphans and widows in their distress and to keep oneself from being polluted by the world." Nice verse. Nice verse. Okay, so I am going to do attendance here. I saw Jared earlier. Let's just move this to the right. That way I can see all of you guys. Crystal is here. Nice. Hello, Crystal. Teddy, I saw. Samuel, are you here, buddy? I don't know that I saw you. Oh, yeah, there he is. Hey, Sam. Oh, you've got... I can't really tell. Your thing's so small. Is it like Frodo is your background or Sam? Might be Sam. It's probably Sam. Your name's Sam. Yuli. Yeah, awesome. Welcome, Yuli. Kathleen is here. Katrin, I saw. Maddie's here. Awesome. SJ. You haven't seen SJ yet? There's a lot of chat happening right here. Don't think I saw him. Make sure if you're just getting in now, you type something for me. Yeah, do not see SJ. Sadie, are you here? Hey, Zion, welcome, buddy. I don't think, unless there's so many S's like Ego. Well, actually, there's not that many. There's just Sam, but he's just typed a lot. Yeah, don't see Sadie just yet. I did see Ruth, pretty sure. I'm pretty sure you said something to me, Ruth. Like early on. Early on. Eric is here. Yeah, there you are. Awesome. Kathleen, skip the dishes order as you skip the dishes. You don't... No one else has to do that. Oh, you just mean... financially speaking. Owen, is Owen here? Yeah, I see him there. Awesome. Benny was here first. He said he was very proud of that. Larissa is here. Lucas was here at the start. Eric is here, and Kendra is here complaining about the food on my screen. Alrighty. How about you, mate? All right. Well, Sadie, let me know if you show up. SJ, you as well. Let's check my messages here. Alrighty. Alright, so I started off. I just wanted to see what y'all did yesterday. What'd you get up to? Yeah, but I don't care if someone's available on Teams. I care if they're available now. Hello, SJ. Welcome. Welcome, welcome. Awesome. I'll mark you here. SJ, where are you, bud? You for your Wi-Fi to be so bad. You just like at a homestay? You back in Korea already? Grade 9. So I'm just fixing attendance. Oops, wrong screen. That was your grades. SJ is here. Just missing Sadie. Kathleen played Roblox. Lucas did nothing. Owen is saying that they actually have to pay attention in science, which is probably an insult to my class, but I'm going to pretend it wasn't. Zion forgets what he did yesterday. Kind of a spring clean-in. Maddie yelled at her brother. That sounds very fun. Owen slept. Sam said, nice. Anyways, I don't need to read these, but very cool. Very cool. Zion. Dog. Jared biked. Very cool. That's great. Oh, cool. A service dog. So is that the only dog in the house? Larissa? You guys like have a dog running around now? Or did you have one before? All right. You guys get... Oh, she hates the new dog. Oh, man. Yeah, that'd be tough. All right, let's get this party started. We're already 8:08 here. So, yeah, I know. Kendra, I had a really terrible April Fool's joke. If you scroll back up in the chat, I said, we're all going back to school tomorrow. Aren't you excited? In all caps. And then no one thought it was funny because I'm lame. I should have played it off. Okay. Let's boogie here. If you guys can open up your OneNotes, you should have something called 5.3. 5.3. Finding the slope of a line. Sweet comeback, Ben. Kendra, that's a good question. I'll show you guys what 5.2 is here. Let's do that. So if we're looking at 5.2, basically, and I can send it to you guys, but I did it in the past and I realized it's like really dumb. We've already done 5.2 before, just differently. So if you look, basically the whole goal was, I already taught you guys this, was like, remember standard form is when you have like, you know, something x, something y, and a constant, whatever. And then if we wanted to graph that, you'd have to find the x-intercept, the y-intercept. So we can graph that. But then this whole lesson was about just changing it to be in, basically to be in its vertex form. Sorry, not vertex form. I'm thinking another class. But to put it in y equals mx plus b, and you can see that here, right? Here's your standard form, and then changing it to y equals mx plus b. Here's your standard form, changing it to y equals mx plus b, and so on. So nothing really new from that lesson, and it was only one page, so you can see last year I was really not feeling it either. I was just like, forget it. This is useless. You don't need to know that. Hey, Sadie, welcome. So we're not going to do 5.2. No need. I'm just going to fix my attendance for Sadie there. Attendance. All right. No, Maddie, we're not going back on April 6th. You guys had email to your parents yesterday that says we're extended the same as the public schools. Okay, yeah, so we're not doing 5.2, no needed, or it's not needed. We're doing 5.3, it'll be actually new material. So that'll be good. Maybe I'll turn my green screen camera on so we can see a little bit better. Alrighty. Ish. Oh, okay. Let's boogie. Yeah, so basically what we're doing, guys, is I've kind of showed you a little bit of this before, but we didn't have good practice with it, and I was just kind of leading it off as a trick. So I want to show how we can use this maybe more consistently. And basically the goal of today's lesson is to find the slope. Not just like if I give you guys a picture. Like I think if I gave you a picture, you know it's rise over run. But there's a new formula for slope we're going to learn today. And it's the one that if you guys were going to go to grade 10, 11, 12, yes, you know slope is rise over run, but you're also it's going to constantly pop in your head. This is another formula for slope. And it'll be another one that you'll know for many years. So basically we're just trying to look at a couple points or different circumstances today where it's not very obvious where you'd have the slope, and we're just going to figure out a formula that allows us to do that. So basically, in this sense here, we've got this problem, and we're going to just quickly read through it, where there's somebody and they were completing a water freezing experiment in which she determined the temperature of the water after 10 minutes. Basically, one of the requirements was to determine an equation and use it to find the temperature. So we put water in the fridge or freezer, I guess, at 0 minutes, and we'd measure it room temperature. Basically, you can see after 4 minutes, it's 18 degrees. After 8 minutes in the freezer, it was 16 degrees. And the more time it's going to spend in there, right, it's going to freeze and actually get messed. So we're going to look at what's going to happen determining the water after 10 minutes. But also we want to find the equation, because that's what she was really asked. Because then if we know the equation of this thing, right? She took two temperatures but didn't give us an equation. If we do know the equation and it's all going down constantly like this, then you can predict any temperature. It doesn't just have to be at 10 minutes. It's not about finding the pattern and counting. It's all about determining the equation. So remember, when we go to graph these things are always listed like x first and y second, right? X first and y second. So it's always the time will be on your x-axis here. So I could write time, and they already have, sorry. And then your temperatures on the y-axis. So I'm going to graph those 2 points. If you guys want to open up your OneNotes with me and graph those 2 points as well, you don't need to watch me do it and then do it yourselves. I think you guys all have the skills to do that. So at 4 minutes, the temperature was 18. So at 4, the temperature was 18. So I should have a point right there. And then at 8 minutes, the temperature is 16. So at 8 minutes, the temperature is 16 right there. Alrighty. Alright, so if we take a ruler and connect those suckers, line is not the prettiest. Really, we're thinking rise over run here, right? We were trying to get ourselves this full equation, so we'd maybe start with our slope. And tomorrow we're going to learn how you could like figure out, like maybe it's hard to predict what this y-intercept is, but tomorrow we're going to figure that out as well. So that's what it says. Tomorrow we'll complete the equation. We're just doing slope today, determining the slope. And I'll show you guys another trick tomorrow about how we get the y-intercept. So what is our rise? Well, you need to predict what's happening here, right? What is the slope going to be? Well, if I'm thinking slope dude, right? Slope dude, he always works left to right. And so if he's going downhill here, he's saying nice, negative. So I do know it's going to be negative. And that makes sense because when I think rise, it goes up, right? But in this case, it's going down. So how many does it go down from this point to this point? Well, it's going down 18 to 16, so it's going down 2, right? So this is going down, I'll just write maybe a -2 in here. And then its run as we work our way over, its run is going from 4 to 8, 4 to 8. So it's going over 4. So our rise over run is -2 over 4, right? And maybe I could show you how we got those points, right? Yowza. In a minute. But anyways, -2 over 4, which you guys know is the same thing. We divide top and bottom by 2. You get -1/2. So the equation is going to be something like -1 over 2x plus b. And we're going to get the b tomorrow. I'm going to show you guys how to get the b tomorrow. Give me a thumbs up or ask a question in chat. I'm also available on Teams there if you're confused about what just happened. You could just divide -2 and 4, Larissa, and you get -0.5, and that's the same as -1/2, but it's going to give you a decimal. It'll give you -0.5 in your calculator. You little jerks. You guys give me 8 dislikes. Well, I just liked my own video, so now I have 2 likes and 8 dislikes. No, it's not 12. It went back down to 11. Okay, now it went up to 12. Anyways, hopefully you guys disliking my videos a lot doesn't flag me by YouTube and I get taken down and stop being able to upload things, because then we got to watch them on Microsoft Streams, and that is way more depressing. I can promise you that. You guys can't chat. It'll just be me streaming there. Anyways, so we've got our slope. It doesn't seem like you guys have questions about that, because all I see is you guys talking about likes. So let's move on. Okay, so how could you possibly get the slope there without graphing it? Like, it was kind of annoying. Basically, it took us a little bit more time than we would have expected, right? So what we're looking for is a quicker method of doing that. And you guys can kind of see it. Basically, we use some numbers, right? If you think about that -2 here, you think about what it was. It was 18, and we had a 16, right? And so it went down 2, right? It went down 2. So you could think of the numbers there. And this was from 4 to 8. And so the difference between those things is 4, right? So really we're looking at the differences in our y values, which would be a rise, right? It's going down 2. And then differences in our x values for the run. So the differences in our y values would be rise, and the differences in our x values would be our run. So let's just see what on earth we did, right? Well, if you look at here, for the rise, we counted along the y-axis. So given the y-coordinates, right, we went down 2 from 16 to 18. Basically, if we were looking at 16 and 18, right, if we want to get that -2, we just do 16 minus 18, right? 16 minus 18. And you would subtract the y values. So we're just subtracting the y values. And basically, if you think of this little symbol right here, this little triangle, that we've already brought up before. It's a little physicsy symbol, right? It just means the change in the y values. And we're going to use this to come up with a formula. We're not just like talking about this in general, we are, but it's going to lead us to come up with a new formula just down below. And then for the run, because that would be the difference. Many we're looking here, right? And that's, we counted from 18 to 16. So if I wanted to figure out what that was, I just did, right? Basically, you're looking at your 16 minus 18. That would have got us that, right? We're subtracting the two values here. If it did 18 minus 16, it's fine. It's cool. It would just give us 2, but we just would need to know it needs to go down 2. So really, we need to find the difference, right? Subtracting them says the difference from here to here. Whereas if you added them, if you did 18 plus 16, right, that would be like, what is that, 34 or something like that? And it's definitely not 34, it goes down, right? You want to subtract them. All right, and then over here for the run, basically we counted along the x-axis, right? We counted from 4 to 8, and so how do we get those? You don't add them together, right? You don't multiply them. Again, you would subtract them. We basically did 8 minus 4. And basically, yeah, you subtract. Again, we're trying to find the difference. When it says change, it could also mean difference. Basically, you're just looking to look through the difference of the two numbers. How far apart are they? And to find how far apart, you subtract things. It's like if I said I was crying from 8:25 to 8:30. How would I figure out how long I was crying for? You do 8:30 minus 8:25. The difference between them, right, is 5 minutes. You don't add 25 and 30. It's not like it's 55 minutes of crying. It's just 5 minutes of crying. So how do we basically get those numbers? Now, basically I want you to think of, and if we come back up here, right, I'm going to scroll up for a second. Why would I cry? Because why not? We had a couple points, right? This here, this looked like the point for 18. And this looked like the point 8, 16. And those 2 points there were graphed here, right? This was the point 4, 18. And 8, 16. Look at the run box. What am I looking at here, Zion? I don't see, buddy. I don't see the mistake, bud. Oh, yeah, it should be run is 4. Thanks, bud. The run. Yeah, good call. That's what we're dealing with over here. Okay, yeah, so anyways, 418 and 816. I don't know what bun means. Those are 2 points, right? Technically, we take them from a table of values, and we can say, oh, all right, they're points that we graphed on our equation here. And so if I line those 2 points up here, and we say, like, there's 1 point A, and so in this case, we could say, okay, this is 418. Actually, my brain is, like, totally not working. What was the other one? 816. And 816. If we look at those 2 points on the line, how did we really get those values? Well, you need to kind of look at this here, right? If we think about our rise over run, just like up above, we said rise was our change in y values, right? We subtracted the y values. We took our 4 minus our 8, or our 8 minus our 4, whatever it would be. And that would have been our run. That would have been our x values. Sorry, I think I screwed that up. But if we look at our 16 minus 18, we would have got our -2, right? That was our rise, our y values. I was looking at the x values. Remember, it's always x first and y second. So rise, we would take our y values and subtract them, and run, we would take our x values and subtract them. And basically, you could see here, like, how does that formula work? Well, let's see if it works here. We say this as x1, y1, because this is like the first x and the first y, like the first point. And then this is saying x2, y2, as in like, oh, this is the second point. And so, yeah, you're kind of looking at those as 2 separate points. And then the change in y is like you're doing your second y minus your first y, and your second x minus your first x. And so how could that work? Well, if we look at our values here, what is y2? Well, if I'm looking at y2, it looks like it's 16 here, right? And if we subtract it from our y1, which was over here, it would be 18. So 16 minus 18 divided by, and then we would have x2 minus x1, so 8 minus 4, right? Because our x2 is here and our 4 is here. So 8 minus 4. So we would have got -2 over 4, which again was -1 over 2. So yeah, basically you're able to look here, and you get the same answer using that formula. So if I knew those 2 points right off the bat, I wouldn't have had to graph this thing. Now you might say, like, Mr. Rose, why did we choose this point here to be 816 and this one over here to be 418? Well, it doesn't really matter as long as you follow the pattern. Do you notice here, like, the y and the x value, both from this one were here. We called this one x2, y2, and we made sure to write both of them first. If you mix up your orders, and so you take your y's and you go 16 minus 18 here on the top, but then instead of going 8 minus 4, you do 4 minus 8, your answer would have been wrong, right? It would have been -2 over -4. So the order actually matters. Here's the deal, though, is that you can choose to rename those things. Like instead, if I did, this one as x2, y2, and this one as x1, y1, just change the name of these things, because you might be like, what the heck? Well, it still will work the same way. Let's just, for instance, I'll do this in red here. Let's just pretend this is x2, y2, and this one is x1, y1. And if we were to subtract things the same way, we basically would get 18 minus 16, right? Our y2 is 18, our y1 is 16, and then divided by x2, which is 4, and then minus our x1, which is 8, so 4 minus 8. So basically 18 minus 16 is 2, 4 minus 8 is -4, and you might go, Mr. Ellis, that is different. But it's not that different, right? Because you remember, if I have a positive divided by a negative, we actually did this earlier where you could bring the negative up, down, whatever. This is a negative slope, and so is this one, right? And so really this is the same thing as -2 over 4, or -1/2. So it doesn't really matter the order, and so hopefully you kind of see that. I'm going to give you guys a minute to copy that down. Doesn't seem like many people are paying attention, so please keep the chat quiet if you would. And get that copied down when you are ready. Give me a thumbs up. All right, awesome. Looks like Sam's done, Cameron's done, Ruth is done, Owen's done, Maddie's done, Eggs is done, Kendra is now done. Awesome. Okay, so Erica's done. Hey, Erica, awesome, awesome, awesome. Thank you for not being a spammer. You as well. Jared and Ruth, thanks for not spamming. And Zion is giving me a T thumbs up. Great. So let's dumb this example down because some of you might be confused. I just want to kind of give us a simpler sense. Hey Sadie, awesome. Glad you're done. Awesome, awesome. So if we want to find the slope for this line, okay, because if we were to, there's 2 points, right? And I could graph them on the x and y axis, right? We could do that, draw it out, like, okay, here's my x and y axis, the point 1, -3 is maybe here, and 4, 6, and then connect it with a line and do all that garbage. But really what we're trying to do here, right, is we have 2 points. This point being A, whatever it is, and this is the worst graph ever. I'm just giving you guys an idea why this would be annoying. And B over here would be 4, 6. SJ's got some sort of money hand. I've never seen that emoji before. That is cool. But anyways, you'd have these 2 points. And so it doesn't actually matter which points you name which. Basically, you can have this one as... this one here is x1, y1, and this one here is x2, y2, but you could also change the names. Basically, the only thing that matters is that you're consistent. We're all going to get the same answer. So how about I call, just because this one shows up first, let me just change the thickness of this for a second. How about I call this one x1, y1, and this one x2, y2. Okay, how about I try that? Because what's really going to happen there then, right? If this is your x1, y1, and if this over here is your x2, oopsies, sorry. I think I just broke something on my computer. Anyways, x2, y2. Basically, to find the rise, right, how much it goes up by, what we're going to do is we're going to take our y2, which is 6, right here, right? And we're going to subtract -3. And that'll tell us how much it went up. Yeah, sorry, Cam, I'll slow down a little bit. Let me know if you have a question. Okay, so I think if I'm going a little slower, our slope, we should have y2 minus y1 over x2 minus x1. And you just got to make sure you line them up, right? So our y2, this would be our 6, right? Minus our y1, so 6 minus -3. Right? We're subtracting our y's, but it's already a negative, right? So we're doing our 6 minus our -3 there. Which, remember, if you subtract a negative, double negative, 2 negatives make a positive, so it'll really be 6 plus 3. And that makes sense, right? Because if I count it up here from -3 to -2, -2 to -1, -1 to 0, that goes up 3. And then I go up another 6, it'd be 9, right? We went up 9. 6 plus 3 is 9. That's why our rise is 9. And then over the run, remember, we're going to do our x2, which is 4, minus our x1, which is 1. So on the bottom, you'd have 4 minus 1. And that actually makes sense, right? Because you're going over, if I count from 1 to 4, right? If I was to go, okay, my run be 1 to 4, we're going over 3 here. So we're going up 9 over 3. And you can actually like totally 6 plus 3, right? 6 plus 3 over 4 minus 1 is 9 over 3. And you guys should know that 9 over 3, right? That one, if you simplified that, that would be 3 over 1. Or if you just did 9 divided by 3, it's a perfect whole number. Right? 3 goes into 9 3 full times. Right? This is supposed to be an equal sign. It's really getting ugly here. Morning, Lenice. So 9 divided by 3 is just straight up 3. So our slope here is 3, which really means 3 over 1, right? Up 3 over 1, up 3 over 1. And that's what that would look like. But I didn't have to draw the graph to do that. Give me a thumbs up if you guys are good. Or hit me up with a question. Sam's good, Owen's good, eggs dabbed. Teddy, I assume that's a good. Yeah, Sadie, that's a great idea. How about, because the next one is a little bit harder, let me give you the first step and see how you guys do. So see if you can find, because this one has 3 points, and we're going to see if they're all on the same line. Let's just do a little side example. That's a great idea, Sadie. So find me the slope between, let's do 2 points. It could be any 2 points. 1, 2, and the point 7, negative 3. So see if you can find the slope between those 2 points. I'm going to pause here. Just going to wait. You guys try this one on your own and see if we get it right. So 1, 2, 7, negative 3. Good idea. And remember to use your formula. So you can call them whatever you want. Just make sure you call them x1, y1 and x2, y2. Benny, you don't switch it just yet. It's just literally think of this as y2 minus y1. So take your y values. I don't want to give the whole thing away, but no, it's if there's a negative in the y or x, we switch it to positive. Not true. Over here, the reason that it became positive was because we did y2 minus y1. We did 6 minus a negative number. It was a negative 3. And that became positive because we did minus a negative. Bunch of people seem like they're confused. We got a lot of different answers. Looks like I see a bunch of negative 5s over 6s. Thanks, Cam. Thanks, Zion. Thanks, Erica. I don't know who Rice Man is. That's a new person. Thanks, Jared. Yeah, negative 5 over 6. I see someone got 6 over negative 5. We'll see what that looks like. Let's try it, right? I want to give a minute or two more as people are just finishing this up. Wow, we have an unbelievable amount of different answers. This is exciting. We'll see which few we get in the middle here. Okay, there's some more negative 5s. Ooh, Kendra switches up life a little bit. 5 over negative 6. It's the same thing as a negative 5 over 6. You're good. Good. Let's maybe try this one. Am I waiting on maybe a couple people? Probably. Just going to pause for a little bit. Killing time. What did I do yesterday? What did I do yesterday? Oh, I bought a fridge, which was cool for my downstairs apartment in that kitchen, so that'll look really nice. It's a Samsung, so that'll be kind of neat. Connect it to my phone and do crazy stuff. And put in a door downstairs. So that was pretty cool. See an answer from Lucas as well. Still just waiting on a couple people that asked for a chance to do that one on their own. But maybe they just don't want to put in the answers. So maybe they're just done. So let's try this out. We're going to do, and it doesn't matter which one you call which. Okay? I'm going to call this one X1, Y1. and I'm going to call this one x2, y2. But you would have got the same answer either way if you had called them something different. And so remember, our slope is, oh, sorry, voice crack, y2 minus y1 over x2 minus x1. And so what we'd get here is we'd have our y2, which is negative 3, right? Thinking y2 minus y1. So we're going to take our y values, negative 3, and subtract y1, so minus 2. So we get negative 3 minus 2 divided by our x values. And remember, it needs to be the x2 first. It needs to be this x2 first. So x2 is 7 minus x1 is 1. So 7 minus 1. This is going to be negative 3 minus 2. You start at negative 3 and then you subtract another 2. So it's negative 5. Over 7 minus 1 is 6. So you should have got something like that, negative 5 over 6. I don't need to have my curtain rod block that. Okay, so here's something new because it seemed like I saw a couple people in chat saying that they kind of understood this. It seems like a bunch of you've got this. Here's what we're going to do. We're going to see if something is collinear, and it gives you a definition down there. If I can scroll over. So if you didn't get this, pause and then come back. Remember, I did help some people the other day on Teams, and you guys can ask me for help at the end of class on Teams as well. There will probably be 20 minutes at the end here where you guys will have some time to ask some questions. So all is good. Let's look here. Basically, right, if you're looking at this, it says collinear. It means they're all on the same line. I want to show you in Desmos what that would look like, though, just so you guys have a sense of what the heck we're talking about. So if I open up Desmos, and I need to actually see what the points are. I'm going to graph these points. So what the points were negative 3, 10, comma 10. So that point popped up. Negative 6, 12. So those two, right? Those two form a line. You could draw a thing between them. But for this third one, I'm going to draw 3, 6 now. For it to be a line, it should be able to follow through, right? I'm going to find the slope between these, and that slope should somehow connect us to the next point as well. So let's see that 3, 6. If I draw that, looks pretty decent, right? If I'm looking at those 3 points right there, they look like they're pretty well in a line, but it might be a little bit off. So a good way to test this is if I find the slope between these 2 points, and then I find the slope between these 2 points, they should be the same, right? If the slope is like here, sorry, I gotta angle my thing the same way as the dots. So if the slope is like this, and then even if it changes just a little bit, then it wouldn't be the same line, right? They would all have to be, right, all lined up, 1, 2, 3 on the same slope, like this. If the 2 points, if the slope is negative, because this is nice negative, right? If they're at negative 2, and then it changes even just a little bit to negative 3 or negative whatever it would be, then they're not on the same line. So for them to be collinear, they all have to be on the same slope. Yeah, Jared, looks like you got a question. What's up, bud? Okay, while I'm waiting for him to type, I am just going to oh, am I cool? Oh, I'm just getting really pixelated, you mean? When I say I got Thanos snapped, it looks like I'm like falling away. Sorry about that. So anyways, we're going to find the same slope, and I'm just going to write a little note of that. Same slope between all points. Same slope between all points. So I'm going to find the slope between here and here, and then here and here. So I'm going to do this first M, and then I'm going to do my second M. And basically, sorry, M means slope, right? So I'm going to find the slope between those two, and if they're the same, then it's on a line. They're collinear, meaning they're all on the same line. And if they're different, then it wouldn't be. So it looked like they were, right? But let's just, for the sake of practice, do this anyways. So maybe you guys could do this. So you don't have to listen to me. If you know how to do slopes, see if you can come up with this. Do your y2 minus y1 divided by x2 minus x1 on the first 2 points. Then do it on the second 2 points, and that'll allow us to compare and see. And find the slope in that way. So let's try it. I'm going to keep going, but if you guys want to do this on your own, you can mute me for a half minute or whatever and just give it a go. Or, you can keep me in the background, and I'll try to be less descriptive. I won't give any answers away, but you guys can feel free. So I'm going to do that first M first. So I'm going to call this one, and I always like to write what they are beside it because sometimes we forget, you know what I mean? And it makes things a little bit awkward. So x1, and this will be my y1, and this will be my x2 and my y2 in this case. So basically you're going to get y2, remember, y2 minus y1. This is going to be a formula that you're always going to remember. If you, I don't know if like Cam and Lenice are still in here, but they're in grade 11 and you still need this formula. You even need this formula in calculus in grade 12. It's the whole actually idea behind calculus, which is funny, this slope stuff. Obviously they do it on more complicated things, but basically it's the entire point of calculus is this slope stuff. So kind of important. So y2 minus y1 would be I said y2 was 12 and my y1 was 10. So 12 minus 10 divided by x2, which is negative 6 minus x1. So negative 6 minus your negative 3. And I'm going to get 12 minus 10 is 2 over negative 6 minus negative. That would be negative 6 plus 3. That would be minus 3. So 2 over minus 3, or you could say, because it's weird to leave the negative on the bottom, that's the same thing as negative 2 over 3. So my slope I see is negative 2 over 3. So I should get, now when I do my second slope here, I should get it as the same. And if it's not the same, even if it's like negative 1 over 3, then they wouldn't be on the same line. Yeah, you can just switch the negative sign. Wait, was that Kathleen the whole time? I thought it was Cameron. Yeah, you can just switch it because remember we talked about how the negative can go on the bottom, on the top, or even in front. It can go anywhere you want. It's the same thing. And then Now, sorry, I was just waiting for you guys. We'll do the second one. Maybe I'll do the second one in blue. It'll be my second slope. So it doesn't really matter. Like I've already called those ones x2 and y2, but you could rename them if you wanted. But I'll just make these ones my x1 and my y1. That way I keep things consistent. So my second slope would be y2, right? So that'll be 12 minus y1, which would have been 6. So 12 minus 6. Zion, you can feel free to do that, buddy. It's the same idea as long as you keep the order the same, but flipping the fraction, like it's just moving a negative up. It's nothing weird. You're not actually flipping the fraction at all. So 12 minus 6, y2 minus y1. Well, it's not pointless and not really a waste of time. But also you don't do y2 minus y1, x1 minus x2 would be y2 minus y1, x2 minus x1. But anyways, I don't think it's much of a waste of time for me to just move my negative up one sign. 12 minus 6, and then you're going to do your x2 minus x1 here, so negative 6 minus 3. So 12 minus 6 is 6. Negative 6 minus 3 is going to be negative 9. So I've got 6 over negative 9. And if you reduce that, right, if I divide the top and bottom by 3, you're going to get 2 over negative 3, which again, same idea, negative 2 over 3. Oopsies. So therefore, because it is a word problem, the points are collinear. They're all on the same line. Because, I'll just zoom out so you guys can see what I'm writing. Because the slope is the same. Guess I could have been doing that in full screen too. Oops. All right. Looks like there's quite a bit here. I would say keep 3. 4 would be a good one to practice. 5 is half a second. Just do 3AB though. Like I feel like that's too much practice to have to do all of that. Don't do 9. Don't do 13B. And then probably not 19 either. Yeah. 19 would have been a good. decent one, but it's fine. So I think probably those 4 questions would be really good practice with the last 20 minutes here. It gives you a good chance. Number 4 is maybe one of the harder ones there because you're taking a point and then a slope and finding another point on the same line. So you'd actually use that rise and use that run to find another point. Adding it to the y's for rise, adding it to the x's for runs. So yeah, I'll let you guys give that a shot. I'm available in Teams if you need me. But yeah, other than that, I'll end the stream because people are a bit sassy today. Not as fun to do today's stream. A little less participation, but yeah, maybe tomorrow we'll be back to being semi-normal. But anyways, thanks for watching. You can go back and rewind if I went a little too fast, but I'm also open to feedback. If you need me to slow down in the future, send me a message on Teams. All right, see you guys.